We're going to begin by talking about squared transformations. So this is one type of transformation which can be used to make a relationship more linear. It has the effect of stretching the values of the upper end of the scale, makes values less than 1 smaller, and values greater than 1 larger. The bigger the value, the bigger the increase when transformed. And we're going to be seeing this real soon. Okay, let us now do this example here, which is asking us to complete the table below. So we need to complete this table. So as you can see, we've got these values here, and we need to square each of them. How can we do this efficiently using our CAS calculator? Well, I've just come to the list and spreadsheet page here, and I've already populated this column here with the relevant information, and I've called it value. What we're then going to do is come over here, and I'm going to put value in again. Do you see how it's bold? It's because we've already defined it. So I want this to be the valued squared. So I'm just going to put SQ next to it. So now I know this is the valued squared. Then I'm going to come to this cell right here, and I'm going to go equals. And as soon as I've done that, it's getting ready to define it as something. And what I want to define it as is the following. I want to go to var, so variables. I want to go to value. So that is the value of this column here. And then I'm going to square it. So I'm saying square this column here. Then I hit enter, and just like that, I've squared all of them at once. So you can see here, 2 squared is 4, and 30 squared is 900. So just like that, we have squared all of these values in one shot. So now we can come over here and we can just fill out this information. So let me move this over here, and I'm just going to move that information over. So it's going to be 0.09, it will be 4, it will be 900, it will be 1024, it will be 3025, and it will be 14400. Now, let's take note of some things that we read up here. And that is that if you, when you square things, it makes less than 1. It makes makes values less than 1 smaller. It makes values less than 1 smaller. So for instance here, 0.3 squared becomes smaller, becomes 0.09. And it makes values greater than 1 larger, and that's the rest of them here. But what I really want you to take note of is that the bigger the value, the bigger the increase when transformed. So for instance, when I square 2, 2 squared is 4. Not that much of an increase. But if I square 120, I get 14,400. There's a huge increase there. So the bigger the value, the bigger the increase when transformed. And that really is important when we come to look at how this transformation looks visually. So here we have x squared transformations. So it stretches out the upper end of the x scale. And the reason why it transforms the upper end of the x scale is because that's where our biggest values are. So x values are squared, y values remain the same. So as you can see here, these values here are being pushed out. They're being stretched that way. And this makes sense because these are our biggest x values, aren't they? This is where our biggest x values are going to be. So when we square them, it's going to stretch them out further this way. The smaller ones are still being squared, but there's less of an effect on them. So too over here, when we're squaring the x values, it's these bigger ones that are being pushed and stretched further that way. I also want you to take note of the shape of the graphs that we're dealing with. Do you see how they kind of curve up like that? And this one kind of curves down. So when you see relations that have this type of curve, you're going to be using this x squared transformations. Sometimes it depends on what the best one is. If we come and look up at our circle of transformations here, you can see them. You can say, oh, that's there, and the other one is there. So when you've got this type of transformation going on, when you want to stretch out the upper scale, so the upper bit here, that when you want to stretch that out, that's when you're going to use it. Okay. Hopefully all of that makes sense on how to use your CAS and basically what's happening. We'll pause here and then we'll jump into an example. How exciting.